Hi, I'm Pat Harrington. I'm the application engineer here at Miller 3D. Here at Miller 3D, our aim is to help our customers actualize additive manufacturing and learn how to integrate it into their existing workflows. One machine that's used to do that is this machine by Markforged, which we represent here at Miller 3D. This machine is an X7 3D printer, which uses carbon fiber impregnated nylon, as well as continuous strands of reinforcing fibers to produce very strong parts. Before I speak more about that, I'd like to share with you a quick story that speaks to the power of additive manufacturing when it relates to strong parts. A few years ago, my team and I were working on repairing a machine. Our goal was to get the machine rebuilt, parts replaced, such that we can run some printed parts on it for a project that we had. The project was under a strict deadline, and the machine really needed to be up and running by the end of the day to meet that deadline. While we were going through many of the items that needed to be replaced on the machine, we came across a solenoid that we did not have a tool for. The solenoid was torqued down very hard. We were not able to get it off with any traditional means, so it became clear that we needed a specialty tool in order to achieve this goal. Specifically, we needed a 25mm spanner wrench in order to remove the solenoid. Now I have that solenoid right here, and this was screwed into an aluminum block, and without the tool, it was almost impossible to remove this part. Now my options were really ordering a part online, getting it sent out, and delaying our project deadline by potentially a few days, or stopping what I was doing, going around to different stores in order to find this specific tool that I needed. Now, there were other things that needed to be done at the time, and that's just lost time that I couldn't afford. So what we did on the team is we drew a spanner wrench file in our CAD software, and we sent it over to the Markforged printer. We integrated in a hole where a dowel pin could be pressed into the spanner wrench, and then within the Markforged 3D printing software, we reinforced the part with continuous fibers to ensure that the wrench will hold up to the high torque that is required to remove the solenoid. So after sending the file over to the printer and pressing print, after 4.5 hours, my part was ready. Took it over to the solenoid, fit right on, was able to remove it, and proceed with the rest of the repair. Is your business one of the many that is having difficulty finding skilled tool makers and machinists to operate equipment in order to produce parts that are needed for your business? Have you ever needed to create a specialty tool but didn't have the time or the resources to machine that out of metal? Have you ever 3D printed a part and just found that it wasn't strong enough? If you've answered yes to any of those questions, then this video is going to speak to some applications that Markforged can help on those points. The first step in creating a strong 3D printed part is to produce a 3D model in a CAD software, whether it be SolidWorks, Fusion 360, or whatever three-dimensional CAD software that your company uses. It will be able to export an STL file. We'll take this format and load it into the Eiger software, which is Markforged's proprietary slicing software, which tells the machine how to build your part. Now we'll take a look at the Eiger software. When the part is pulled in, we can choose which material that we'd like to build the part out of. Onyx is our nylon with carbon impregnated. We also have a flame retardant version, and you're seeing some of the metal materials that Markforged offers as well on another platform. We also have the ability to choose which reinforcing material we'd like to use: fiberglass, carbon fiber, Kevlar, or a high strength, high temperature glass. For this part, fiberglass will be more than sufficient, which will allow us to crank on this handle quite a bit and achieve the desired result. We also have the ability to change some settings, which is turning support material on and off. And then we have the ability to play with infill settings. Each part has different infill patterns that can be used. This is less important on Markforged than it is on other printers, because with the ability to inlay reinforcing fibers, that is what's going to take a brunt of the load rather than the infill on the plastic part itself.
With fiberglass selected, we can also go over to this reinforcement tab and choose how the fibers will be laid into the part. We have two options, isotropic fiber or concentric fiber. For this part, with the way it's loaded, concentric fiber is the best for resisting load rotationally in the Z direction. After that is selected, we can go ahead and hit save, which will send the part through the software and slice it up into layers about 4/1000ths of an inch thick, which will allow the printer to build them step by step. Once the slicing is complete, we'll go into an internal view of the part where we can take a closer look at what the printer is doing on the inside, most notably how the reinforcing strategy will be done. You can see here on layers 95 to 98, we're reinforcing with fiberglass, which is depicted in the yellow lines. And we can increase how much fiberglass is put in on each of these groups of layers. So doing so on the top and bottom of the part where the loads are the most concentrated will increase strength quite a bit. The software will automatically populate those layers, and we also have the ability to add in additional layers of fiber wherever we see fit. So for example, right in the middle of this part, we'll put some additional fiberglass. Now our part is reinforced with fiberglass, and we can take a look at a cross-sectional view, which will allow us to take a look at individual layers. You can see the infill as well as the reinforcing fibers, and then you can also see in purple support material that will be laid down in the hole for the dowel pin. This will be poked out and removed quite easily after printing. Once those final tweaks and fiber reinforcement are complete, we'll hit save, and we'll go ahead and hit the print button. This will allow us to do a final layout on the build bed of where we'd like our part to be printed, as well as add other parts to the build if we'd like to make more than one part at a time. After doing this, we'll have an updated material cost and print time in the top left corner, and then we'll go ahead and choose which printer to send the job to. We can go ahead and hit print now, and the job will start automatically. What I've demonstrated with this Eiger software demonstration is that we can take a part from CAD, put it into the Eiger software, and reinforce the part such that it's strong enough for your application. I've also demonstrated that the time it takes to send a part through this workflow is significantly less than if a programmer were to take this part and set up a program for CNC machining. I also touched on the fact that this is an automated process. This printer can be run unattended overnight or throughout the business day without any human intervention, which keeps your machine operators focused on projects that make your business money. We can also use this technology for other types of manufacturing applications, like these jaws, which we're going to use to hold some metal 3D printed parts in a vertical machining center and remount some of these holes to fit some dowel pins. So I urge you to contact us here at Miller 3D so we can take a look at your business and see how additive manufacturing can help you save time and money. As Greg Mark, the inventor of this type of printing technology, says, with Markforged, we print tools, not toys. I hope you've enjoyed the video.